The pitch of a propeller is measured by means of a batten and cord. The horizontal ordinate is found to be 40 centimeter, while the vertical ordinate 1.15 meter at a distance of 2.6 meter from the center of the box. Calculate the pitch of the propeller and the blade width at that point. Question is asking us to determine pitch of the propeller. So we must be very clear about now what is pitch of the propeller. It is
Yes.
simply the axial distance covered in one rotation. When the propeller is assumed to be working in an unyielding fluid is similar to a solid
Okay.
without having any losses or slips. Clear?
Yes, sir.
Okay, that's what we
There's
are
no loss.
interested in. So now let's say this is the propeller and its pitch is being measured with the help of batten and cord. As I might have told you earlier also that two weights will be attached onto a rope and the rope will be allowed to fall down. Okay. So
Yes,
the
sir.
one of the blade is kept horizontal. It is pointing towards you right now. Okay.
Yes.
Now we will arrange a horizontal batten under it, and using spirit level we will ensure that it is perfectly horizontal. And now horizontal ordinate and vertical ordinates will be measured with the use of a scale. These are the ordinates the question is talking about. Now question is basically talking about horizontal ordinate BC and vertical ordinate AB. Clear?
Yes, sir.
Okay. This is face of the blade and AC is a line passing through face of the propeller blade. This is a phi, which is pitch angle at that particular radius. Okay. Here I have taken a blade which is very simple in geometry and having a constant pitch throughout its radius. But you might have noticed the propellers which have got plenty of curvature, okay, in their blades. They are basically having a varying pitch. Okay. Right now we need not to be bothered about that because we are taking into consideration one particular radius. For time being, let us just concentrate on this. Look at this triangle and can we utilize some trigonometric functions? Tan phi
Yeah.
will be equal to
Tan
the
phi is
ratio
equal to
of opposite
opposite
to
side, adjacent side.
adjacent. Okay, yes. So the ratio of BC to AB will be tan phi. Now we have been given BC, the horizontal ordinate, as 40 centimeters, which will be same as 0.40 meters. I'll tell you why we are converting in meters, because we are taking ratio. The units must be same.
Yes,
The
sir.
vertical ordinate AB is 1.15 meters given in the problem. So they will both be helping us to have the value of tan phi. And this will finally
Yes.
help us to determine the pitch angle phi, 19.18 degrees. Understood up to here?
Okay, sir. Yes, sir.
Yes. Now let us look at the same propeller, okay, but in a different perspective. As if we are taking a random radius away from the center of the boss. So pitch will be the axial distance covered in one rotation, and one rotation, I mean the total distance covered in one rotation will be 2 pi r. R is the distance taken from here center to this. Imagine the radius of the cylinder from center of the boss. Clear?
Yes, sir.
If I expand this cylinder, I'm going to get a rectangular form. One dimension will be
Pitch
pitch, one dimension will be 2 pi r.
2 pi r.
Correct? And
Yes, sir.
this purple line is basically that diagonal of the rectangle, and it is going to be the helix. That means
Yeah,
the
the path
path
of the boat.
actually covered by simultaneous rotational and axial motion.
Mm.
This angle which it makes with the plane of rotation is phi angle, same as pitch angle, what we just saw in the previous slide.
Yes, sir.
Right from here, pitch angle can be expressed as pitch upon 2 pi r. P
Yes.
upon 2 pi r. So right from here, pitch will be equals to the product of tan phi and 2 pi r. Tan phi we have determined in the previous case. R we are given R 2.6 meters, as we can see 2.6 meter from the center of the boss. Okay, this is small r. So 2 pi into 2.6 into the value of tan phi from the previous slide. Okay, where I explained you how to determine that, and it is giving us pitch as 5.6817 meters.
5.6.
Understood?
Yes, sir.
This was asked in the problem, the pitch of the propeller. We are done with that.
Proper.
But question is also asking blade width at that point. What does that mean? Look at this diagram again. This diagram. Blade width at that point, that means you need to determine AC. And can you simply utilize Pythagoras theorem for the purpose of
Yes, sir.
determining AC?
Sine
Or
theta
you
is
may
equal
also
to
utilize trigonometric functions.